All right, so this is the central limit theorem. So when it comes to our case, we're going to skip the first page of it because we're not in class anymore, so we have to do that portion. So we're going to just go to the back or the next page and talk about this one here instead. Okay. So what it means by the central limit theorem is, notice when the last scenarios we talked about is, well, what if one person, a public, right, a man can go through it? Well, the question now becomes, what if I want more than one person in my probability, right? So like want 2 or 3 people or even 4 people in it. So that's what the central limit comes into play as well. If I want more than 2 people, so 2 or more in my probability, so like 5 people, 7 people, it's not the AND rule, which is a little tricky. So not actually multiplying, but we have to associate it inside the z-score itself. So if I want more than 2 or more people, this is going to be our new z-score formula. Very similar to the one we just did, right? Almost identically, except for this bottom square root of n stuff. Okay, that's it. That is the only difference. The work is identically the same, just finding the z-score is just a little slight different when it comes to it. So let's just do this example to see how this will work out. So we want to find the probability that 9 people will have a height less than, right, less than 162 inches when the mean is 157 inches, the deviation is 8.3 inches. So we want everything less than, so we want the probability of x being less than 162. So we need to convert the value of 165 to a, sorry, this is going to be 162. Very sorry, it's supposed to be 162 to a z-score using our new formula. Well, again, right, so we want 9 people, so n is going to be 9. So we're using this formula, we plug in everything we know. So x is 162, mean is 157, sigma is 183, and then the square root of 9 at the bottom. Now, I always like the parentheses to show you guys order operations. You have to do this first, kind of like we did last time. So that subtraction is just 5, right? Doing this, square root of 9 is 3. Then dividing gives you 2.77. And finally, you divide the 5 into that, and it gives you a final answer of 1.89. Okay, and then that's just the z-score. Now we do the same thing we did in the last section. We find area to the left because we'll want, less than. So that gives us the value of this, and that's going to be your answer. Okay. Very similar section to the last one. The only difference, again, is just now this new formula. Okay. So let's just try them out so you can see how this would work out. Okay. So question 1. Assume that weights are a mean. Assume the weights of mean are, sorry, still speaking men, sorry, are normally distribution with a mean, so again, normally distribution, right, it's a key word, with a mean of 172 pounds and standard deviation of 2.91 pounds. Find the probability that one man is randomly selected and his weight is greater than 175. So n is 1. So here's the key. If n equals 1, we're going to use the same z-score equation we've done so far. Nothing changes, right? So it's essentially the same question we did the last section. So let's just do this real quick. So we want 1. So mean is 172, and we have 175. So we want everything greater than. So I'm shading everything on the right-hand side. So I want the area to the right of that value. Okay. So first off, we got to find the z-score associated with that. So 175 minus 172 divided by 2.91 gives us a z-score of 1.03. Okay. So we do this part. Again, right, this is area to the right. I first have to find area to the left of it. So if I find area to the left of the z-score, 1.03, it should be 0.8485. And since we want area to the right, so we do 1 minus that number. And it should give us our true answer, 0.1515. So this is what we're looking for, right? That's the probability that it's greater than a man is greater than 175 pounds. So that's your answer. Okay. So that's the same thing we did the last section. Now, so part B now is this new section. So now I want 22 men. So that is our n, right? 22 men. And the good thing is it's the same scenario, right? So it's the exact same process, except for finding z-score is going to be a little different. So 175 minus 172 divided by 2.91 divided by the square root of 22. So like that. Okay. So if we follow the example we did above, right? 175 minus 172 is 3. And now we got to do this portion. So 2.91, well, the square root of 22 is not a nice number. So let's see, with the square root of 22, we'll round it to 3 decimal places. So 4.690. So now we divide those. So this is 3 over 0.620, which gives us a z-score of 4.84. And again, now we do the same thing. We want area greater than that. So here's 4.84. So everything is greater than that. So, well, that's going to be 0.0002 because everything to the right is 0.9998, right? Because that's way off the chart. And since we want everything to the right, our answer is 0.0002. And there we go. That's our answer there. So very similar to what we did last time, right, when it comes to it. Just a little tweak as well. So why don't you guys try, we'll do 6 together. Oh, C says at the end, is it likely to see 22 men have weights greater than 175 or 1 man? Well, since this was about 15% and this is like less than 1%, therefore, finding 1 man greater is a better chance of likelihood of happening, right? Okay. So now for 2, 3, and then 4 is on the next page. Go ahead and try them out. 2, 3, and 4, and then we'll do them together. So 3, 2, 1, pause, try them out. All right, so hopefully you guys tried them out. So now we're going to do them together. So I'll go a little quicker since you guys have them already. So membership to Mensa requires an IQ score above 131.5 if IQ scores are normally distributed. So again, notice normally distributed with a mean of 100 and a standard deviation of 15. If a person, so I want n is equal to 1, is randomly selected, find the probability of getting an IQ score at least 133. So that's the probability of x being greater or equal to 133. Okay. So we got to find the z-score with that, minus our mean of 100 divided by 15. So what is our z-score here? It's 2.2. So now let's see what we have. So here's 2.2, and we want everything greater than that. So we want the area to the right of that value. So 2.2, this is a 0. So area to the left of 2.20 is 0.9861. So 1 minus that value gives you what our true answer, 0.0139. So that is the probability of finding someone with an IQ score of at least 133. Okay. And then B is identically the same, except now we want n is equal to 9. Right? So same exact question, right? But the difference is now we have used the central limit theorem to help ourselves out. Okay. So this is still 33. Square root of 9 is 3. So this is 15 over 3. So 15 over 3 is 5. So this is 33 over 5, which gives you a really big number of 6.6. And again, it is the exact same question. We want everything to the right because everything at least is greater than this. So just like our last one, it's kind of redundant because everything to the left is 0.9998 minus, and it gives you that. So that is the probability of 9 people having IQ scores of at least 133. Okay, question 3. Ski condolias carry skiers to the top of a mountain. It bears a plaque stating that the maximum capacity is 14 people or 2,352 pounds. That capacity will be exceeded if 14 people have weights with a mean greater than 168 pounds. Assume that weights or passengers are normally distributed with a mean of 175.4 pounds and a standard deviation of 41.6. So there's our mean and standard deviation. So same framework as above. A is just 1 person. B is now 14 people, right? So we want A individual, so that means n is equal to 1. So we want greater than 167. We want the probability of x being greater than 167. Okay. So if we do that, we first convert this to a z-score. So 167 minus our mean. Our mean was 175.4 divided by our standard deviation of 41.6. So this z-score is going to be negative 0.20. Okay. All right, so if we just look at this curve, what are we looking at here? Here's negative 0.20, and we want everything greater than that. So we want all of this area here, which is area to the right. Okay. Again, right, so hopefully you guys get the pattern. So first find area to the left of negative 0.20 and then subtract it from 1. So the area to the left of negative 0.20, it should be 0.4207, and then minus the 1 gives us our final answer of 0.5793. So the answer is 0.5793. So that should be a decimal. Okay. And now B, again, identically same, except n is going to equal to 14, right? So we have z is equal to 167 minus 175.4 over 41.6 divided by the square root of 14. Okay. So let's see what we get. So I did this all really quickly. It should give you roughly 11.12ish when you're off, and then 167 minus 1 divided by 11.12ish. So it gives us a z-score of negative 76ish. So 0.76. And now we do the same thing. Okay. So find the area to the left of negative 0.76. So hopefully you guys got 0.2236. And again, since we want area to the right, subtract it from 1. This is 0.7764 as our final answer. Okay. So that's a probability of 14 people have weights greater than 167. Okay. All right, and the last one is Kanakos. This is an interesting question if you guys want, right? So Kanakos are filled with, have a mean of 12 and a standard deviation of 0.11. Find the probability that a sample of 34 coats will have a mean of 12.9 or greater. So we want the probability of X being greater or equal to 12.9 ounces. And just a little, almost close to an ounce more, right, when it comes to it. So since N is going to be 34, we have to use our z-score. So this is going to be 12.9 minus our mean, which is 12, divided by 0.11, divided by the square root of 34. Okay, so let's see what we get totally after we do this calculation. And if you got something outrageous, there's a reason for that. So I got roughly that. Okay, so it's a ridiculous number, right? So since you want everything to the right of it, because you guys can probably already tell without even finding the area, it's going to be super, super small. So again, for our case, since we don't have a portion, look at our formula sheet, it's going to be, again, just 0.002. Believe it or not, the actual answer is, I believe, 9 zeros before you even get a number. So Coke, make sure you don't get, anything, an extra ounce in their cans, right? All right, so that does it for this section here. That is the central limit theorem itself.